Lesson 6-1, Properties of Exponents. These are the laws of exponents. They basically give you a framework for how you would simplify exponential expressions depending on what you're given. So the first one has to deal with a negative power. You can always switch a base with a negative power into a fraction. Or if you have a fraction with a negative exponent, you can move it up to the numerator. Anytime you're multiplying two exponential, monomials that have the same base, what you can do is combine them together by adding the powers. In property 3, if you have one base raised to a power raised to another power, it's the same thing as the base a to the product of m times n. If you have more than one base in parentheses, like ab to the power of n, it's the same thing as a to the n, b to the n. And then the last few have to do with fractions. So in property 5, if you have the same base in the numerator and denominator of your fraction, you can simplify it by subtracting the powers. If you have two different bases, a over b to the power of n, that's the same thing as a to the n over b to the n. And in 7, if you've got a fraction to a negative exponent, what you can do is take the reciprocal, flip the fraction over, b over a to the positive power. And then finally, anything to the 0 power is equal to 1. So let's use these properties to simplify some expressions here. So the first one, we have negative 3x squared y to the third times 5x to the fifth y to the sixth. The first thing that we want to do is recognize that we're multiplying everything here. So we're going to start by multiplying negative 3 times 5, and that's negative 15. And now I'm going to put together the ones that have the same variable. So x squared times x to the fifth, that's x to the seventh, because we want to add those powers. Y to the third times y to the sixth, we can put those together because they have the same base, and we get y to the ninth. Negative 15, x to the seventh, y to the ninth. Number 2, we have a fraction here. And remember that a fraction means we're dividing. So we've got negative 2 over 18 to begin with. Negative 2 over 18 reduces into negative 1/9. And then to simplify the a's and the b's, we're going to subtract the powers. A to the third over a squared is a. B to the sixth over b squared is b to the fourth. So we've got negative 1/9 a, b to the fourth. All right, number 3, we've got a fraction in parentheses raised to the third power, 1 over w to the fourth z squared to the third power. Now, one way to do this would be to rewrite it 3 times and think about this fraction being multiplied by itself 3 times over again. But the other thing we can do too is just take the top and the bottom to the third power. So if I take 1 to the third power, that's 1. If I take w to the fourth to the third power, a power to another power, the shortcut is to multiply those. W to the fourth to the third gives me w to the 12th. Z squared to the third power, that's z to the sixth. We're multiplying the exponents. And so I've simplified this into 1 over w to the 12th, z to the sixth. Okay, let's try number 4. Again, we've got the power to another power rule going on here, and so I'm going to start there by simplifying these powers. We need to multiply them anytime you have a power to a power. So rewriting this, I've got n to the 9th, 3 times 3 is 9, times n to the negative 9th. Now, because these have the same base, n, I can simplify this again by adding up the powers. Now, if I add up 9 and negative 9, I get 0, and we know that anything to the 0 power is 1, so this whole thing reduces into 1. All right, 2 more. I've got a lot going on in these examples, so there's multiple steps to do here. The first thing I would do is maybe simplify what's in parentheses, because I noticed that I can take negative 6 divided by 3. That gives me negative 2. And I've got the same variable here, x to the 6th over x to the 3rd, so I know I can simplify it. So in parentheses, I've got negative 2. And the rule here is to subtract the power, so 6 minus 3 gives me x to the 3rd. And now that's still raised to the negative 2nd power. I've got two bases in here, -2 and x to the third. I need to raise both of them to the -2nd power. So -2 to the -2nd. We'll figure that out later. Times x to the third to the -2nd. I know that the power to another power means multiply them together, and I get x to the -6. Now, using what I know about negative exponents here, I can rewrite these as fractions. 1 over -2 in parentheses squared becomes a positive 2 power. I'm putting it in the denominator, and x to the positive 6 power. So anytime you want to get rid of a negative exponent, you can rewrite it as a fraction by putting those in the denominator. So -2 to the positive 2nd power, x to the positive 6 power, and you just put a 1 on top. So now my final answer, this part here needs to be simplified. -2 squared means -2 times -2, so that's +4, and I get 1 over 4x to the 6th. That's my final answer. Okay? Number 6. I've got 2a squared b, and then on the bottom it looks like I have some simplifying to do. I've got in parentheses 2ab to the third. By the way, that's 3 separate bases, and all of it's to the -2nd power. Now, I can kind of use the negative exponent rule here first as well. If your negative exponent is on the bottom of the fraction, you can make it a positive power by moving it up to the top. And so that's exactly what I'm going to do here. The 2a squared b can stay in the numerator, and then because this had a negative exponent down on the bottom, I can switch it to the numerator and make it a positive power. So now it's -2ab to the third to the positive 2nd power, and I no longer have a fraction. That's part of property number 1, I believe. Okay, so now let's work on simplifying. So I need to take care of this power first. So I've got a 2a squared b that I'm going to leave alone for now. And now everything inside the parentheses needs to be raised to the 2nd power. So -2 squared again is +4. A squared is a to the 2nd power. And b to the third to the 2nd power is b to the 6th, because I'm going to multiply those powers. Okay? Now it looks like I'm multiplying two monomials here, so easy enough. 2 times 4 is 8. A squared times a squared, that's a to the 4th. We're adding the powers here because I've got two like bases. And b to the 1st and b to the 6th, when you multiply, you get b to the 7th, adding up the powers. So we've got 8, a to the 4th, b to the 7th. Okay, now one thing I want to mention about all of these problems that I've done is there's multiple ways to do them, multiple ways to get your answer. So there's not just one correct route to go. You could go different routes here. The way I do it might not be the way that you do it, or you might notice that there's different properties that you can use first before you move on to the next one. But anyway, as long as you get the correct answer and you're following the properties, you'll be good to go. Okay, last thing is scientific notation. Just to refresh your memory on scientific notation. A number in scientific notation is written as a times 10 to the nth power. It's always times 10 to a certain power. However, that first number, a, has to be between 1 and 10. So it can't be like 12.5 times 10 to the second. It has to be between 1 and 10. So something like 5.7 times, I'll write an example here. 5. Okay, there we go. 5.75 maybe times 10 to the 6th. That's a number in scientific notation where the first number is in between 1 and 10, and you've got 10 to a certain power. Okay, so here's an example of two numbers in scientific notation, and we're dividing them. 4 times 10 to the 16th over 3 times 10 to the 8th power. And you want to simplify this. Well, there's an easy way to do it here. Instead of expanding the numbers out or using your calculator, you can simply calculate the first part and write it as a decimal. So we've got approximately 1.33, or we could say 1.3 repeating, that'd be just fine, times Now we know how to divide these, 10 and 10. We've got the common base here, so I can simplify them by subtracting their exponents. Anytime you've got a fraction or division, you can keep the same base, but subtract their powers, and 16 minus 8 is 8. So dividing these numbers in scientific notation, I get 1.3 repeating, that's 4 divided by 3, times 10 to the 8th power. By the way, your first number in scientific notation too should always be a decimal. So you won't want to write 4/3 times 10 to the 8th. Write it as a decimal. This tells you that the decimal needs to be slid 8 spots to the right. All right. We're done.